Bonjour à tous et bienvenue à la compétition étudiante dans le cadre de Vitrines 2022. Mon nom est Béatrice Perrier-Agostini, je suis directrice relève et main-d'œuvre chez Aéro Montréal et c'est un plaisir de vous accueillir aujourd'hui. Donc j'aimerais avant de commencer remercier les membres de nos jurys, donc avec la présidence de Fassika Fieke de Bombardier, la coprésidence de Clotilde Petitjean de Criac, mais également nos autres juristes, c'est-à-dire Pierre Gillard de l'ENA et du MAC, Marianne Chouinard de CAMAC, David Rancourt de l'Université de Sherbrooke, Alexandre Sylvain de Stelia et Marie-Félicite Gignac de l'Aéroport de Montréal. Merci beaucoup d'être présents et de donner de votre temps.
Now let's move on to the third part of our solution. As you can see, nowadays in Montreal Airport, this system is used, which is called hydrant system refueling. And you can see there is a fuel farm, and fuel is transported to these hydrant pits via pipelines which are underneath the airport. So at each gate there is a hydrant pit, and when the aircraft arrives at the gate, the dispenser trucks goes to the aircraft and connects the aircraft to the hydrant pit and then dispenses the fuel. However, when we're using ACF, we cannot just replace the entire pipeline with ACF instead of kerosene, because in the initial stages, only a small number of aircraft will be using ACF. Majority will still be using kerosene. Therefore, we propose another system called the segregated system. In this system, there can be two options. Number one, well, we can use trucks called Bowser trucks, which will carry the fuel ACF from its fuel facilities directly to the aircraft. Option two, we could create small fuel ACF tanks. And then, as time passes and the demand for ACF increases and becomes larger than the demand for kerosene, then we will substitute the kerosene inside the pipeline with ACF. Next, we propose another improvement in the refueling process. Currently, refueling is done completely manually, and it takes at least 2 employees to refuel the entire aircraft. And also in larger aircraft, sometimes elevators are used, so it's not always that safe. Hence, we propose robotic refueling. As you can see from the clip, the robotic refueling is currently used in the mining industry to refuel the mining trucks. However, many companies are manufacturing and doing research in robotic refueling parts in the aerospace industry as well. So as you can see, there are several advantages of it. Of course, the number one would be we do not need any local operator on site. And also this robotic refueling is going to be safer. The full refueling is going to be faster, and we are going to minimize spillage and environmental contamination. Now that we have proposed solutions on various aspects, so what are the consequences? What are the consequences in terms of costs? Well, the very first will be that operation of ACF is a bit more expensive than that of kerosene because of the relative maturity of ACF, and also the cost of training of the new staff for the new technologies, and then setting up new blending facilities. All of these will be very expensive. So how are we going to compensate these costs? Well, we propose partnerships between universities, research departments, and aerospace companies. And also, going green will attract a lot of government funding, tax exemptions, subsidies. And also there are many organizations which provide funds for companies that are, for companies to encourage them to be more eco-friendly and more sustainable. And also nowadays people are becoming more environmentally conscious. So we believe that many travelers will be willing to pay a bit more per flight to have a more environmentally friendly flight. And at the end, going green is always good for the stock market. So the companies that will involve ACF in their aircraft, their market share will definitely go up, and this will attract even more investors, and thus we're going to get more funding. So, as we can see that this temporary cost will reduce the carbon emissions and at the end save our mother planet. Next, we are going to look at the safety and reliability of our solutions. So, of course, we are going to put more work and more investment in additional research, and we will do more tests on the ground and on the air. for vehicles, for aircrafts using SAF. And also, we would propose employment of focus groups. That is, we will take people working in the aircraft industry in the refueling process and from different departments, and we'll have a survey. We'll ask them what they think could be improved or modified, and thus we'll have a large enough survey with the potential improvement areas identified. Thus, we're going to work on the safety and reliability.
Donc maintenant, je vais vous expliquer pourquoi on a décidé d'aller avec les batteries électriques et plus précisément des batteries au lithium-ion au lieu de l'hydrogène.
Comme on a vu, l'hydrogène est utilisé dans l'aérospatial depuis...
Bien, félicitations et merci à nos 3 équipes finalistes qui ont présenté aujourd'hui. Bravo.
Nous avons eu de très bonnes discussions. Je voudrais d'abord commencer par remercier toutes les équipes pour le bon travail que vous avez fait.
Okay, so what we found is that the presentation was very high quality. You were balancing from one student to the other so that you had a very good presence. You were very professional, and that was really greatly appreciated from us. And the scenario you chose was the most realizable, like doable in the short term. This was the one that this is the one that is being studied right now. So definitely you had plenty of information that was interesting, and you had a very good plan of implementation of the program. We found it very complete, very well studied.
Bonjour, je vais suivre ma collègue donc pour le commentaire de l'équipe B qui a fait la présentation en français, en très bon français d'ailleurs. Donc d'abord on aimerait souligner la qualité du rapport que nous avons reçu. Très bien documenté, très bien structuré. Peut-être qu'on aurait aimé que la présentation le soit aussi bien structurée, qu'elle accompagne un peu plus le lecteur. Je ne sais pas si vous avez l'intention de poursuivre des études en ingénierie, mais c'est vrai que peut-être ça va être des attentes dans le futur.
Alors pour l'équipe C, tout d'abord, félicitations, vous avez également abordé un problème qui était difficile. Qui est quand même complexe. De mettre de l'hydrogène dans un avion n'est pas une solution facile et c'est pas très connu non plus. Vous êtes basé sur l'approche qui est très active en Europe, donc beaucoup de faits que vous avez mentionnés par rapport, entre autres, à Air Liquide et en fait ce que Airbus fait présentement. Donc ça a été très bien détaillé.
Alors, l'équipe en deuxième position est l'équipe A. Bravo. 2 personnes par ici. Ah oui, bien sûr. Oui, pour la photo. Ok, attention, on y va. Je ne sais pas. Très bien.